Welcome to the second part of today's session. And it's my pleasure and honor to introduce the speaker of present session, Dr. T. Vinay Kumar sir. Vinay Kumar sir has completed his BTech and MTech from GIAN to Hyderabad and PhD from NIT Warangal. Currently, he is an assistant professor at NIT Warangal. His area of research includes power electronic and drives, direct torque control, predictive torque control, open-end winding, induction motor drives, multi-level inverter, hybrid electric vehicles, and renewable energy interfacing. Vinay Kumar sir has around 45 publications, of which 27 are journal publications and 18 are conference publication. And he was awarded an Early Career Research Award by SERB in 2019 and also SIRE Fellowship Awards by SERB in 2022. Vinay Kumar sir has granted and completed 4 SERB projects, and under his guidance 5 PhD scholars has completed PhD, and there are 2 ongoing scholars. And he is also a faculty advisor for Electrical Engineering Society. Thank you, sir, for accepting our request for delivering a lecture in today's session, and welcome to the session, sir.
Yeah, good afternoon to all. Now it is very hard time to me to transfer the energy. Now already 2:45. Just now we had lunch, right? It is very big challenging for me to transfer the energy effectively, right? I will take care, no issue. In between I will try to ask questions, right? If you know, you can answer, otherwise I will see this session should be like interaction session. Don't feel it will go in one direction, right? So main object of today's session is we'll try to understand, see first 30 to 35 minutes we'll try to understand what is the need of model predictive controller, right? This is very important. If you want break any pattern, important thing is you should know what is the existing pattern, right? What is the logic behind the existing system, we should know clearly. Once you know the existing pattern, right, in detail, right, if you want to do modification or if you want break the pattern, it is not a big challenging. See, now, see, by title itself will give 2 challenges. Now, anyone, see what are the big challenges with respect to model predictive control? Title, if you analyze the title in detail, you will get clarity about what is model predictive control. See, before discussing, before understanding what is model predictive control, how to use, particularly how to adopt this technique for motor drive control, right? See, first, what is model predictive controller? What is need of model predictive controller? We should know before starting the session. Now tell me, see, title is, it is reflecting. If you go analyze the title in detail, there are 2 challenges are there with respect to model predictive control. What are the 2 challenges? Design of the model. We are not designing any model here. You have to understand the model. You have to understand the existing model. Next. No. You forget about application. Anyone? There are 2 challenges are there here. Actually, model predictive is nothing but combination of 2 things. We are targeting 2 parameter. Yeah, okay. Prediction is a very big challenging. Any other? Control. There are 2 things are there. See, these 2 are very important parameter with respect to model predictive control whenever you want to adopt this technique, right? See, important thing is first you should know actual system characteristics. Without knowing the behavior of the actual system characteristics, what parameter we need to target with respect to electric drive, we don't know the control parameter, it is very difficult to adopt the model predictive control method. The big challenging in model predictive control is predicting the system behavior, right? At the same time, control the variable. You got my point? Model predictive control. First, you need to take care about, see what is the status of the variable in the coming sample. You have to predict, right? After that, after predicting the value, how we can optimize, what switching state we need to adopt to minimize the error is so challenging, right? Particularly in model predictive control. Now first I will try to focus on motor characteristics. This is very important. See, you all are electrical scholar. By taking this example, definitely you will get clarity about how to identify the parameter, control parameter or target parameter with respect to our system. So in today's session, our system is a motor. So for understanding purpose, initially what I will do is I will take DC machine so that you will get more clarity, right? Clear? If you know the characteristic equation of the particular system, it is not a big deal to identify the, see, if it depends on cause and effect, it is very easy to decide the control variable. You got my point? See, according to Newton's law, what is Newton's law? Newton's first law. Anyone? If you want change the state of objective, it required external force. Without applying the external force, we cannot do any job. You got my point? So here, if you take electric motor, if you take any electric motor, there are 3 circuits are there, whether it is a DC system or AC network, AC motor or DC motor, or even if you take special machines also, BLDC, PMSM or any machine. Finally, there are 3 circuits are there. What are the 3 circuits in electric motor? One is called armature circuit, another one is called field circuit, next mechanical circuit. You got my point? Our system is a dynamic system. Always, see, load is connected to the motor shaft. You got my point? See, even if you take DC machine or AC machine, finally our aim is, our objective is with respect to drive. What is drive? Drive is a basically mechanical energy producing device. By using motor, we can able to produce the mechanical power, right, effectively compared to IC engine or compared to hydraulic drives. If you adopt electric motor in drives application, right, we can control the speed, we can control the torque instantaneously. The beauty of model predictive control is instantaneous control is possible. Instantaneous control is so important in high performance drives application, wherever high, particularly in electric vehicle application or aerospace application or submarine application or in robotic application, instantaneous position control or instantaneous speed control is required. If you want to change the shaft speed or shaft position, essential thing is we don't have any freedom. You need to control only torque. Torque is the primary control parameter to change the dynamics of the speed of the shaft or to change the position of the shaft. If you want to change the position, what you need to control? How we can change the position? Now, there is a shaft is there. I want to change the position of the shaft. What it required? It required speed. Speed you have to change. By changing the speed, we can change the position. But speed, how it will change? What is the logic? Right? See, what is the main cause component to change the speed? Torque. Torque is the main cause component to change the speed. Right? So, right, torque is the primary control objective, particularly in electric drive system. If you take DC drive or AC drive or special machine also, if you take any electric motor, our target parameter is torque. Primary target parameter is torque. Why I'm particularly telling, see this one, control mechanism or feedback mechanism or feed forward control techniques, everything will come based on the system characteristics. See, if you are unable to understand the system behavior, it is very difficult to develop the control method. Control method, it will come. It is a simple subpart of the actual system. If you know the system behavior, if I know the student behavior in classroom in detail, mentally as well as physically, definitely we can change our modulating value. By changing the modulating value, we can transfer the energy effectively. Otherwise, without knowing the student characteristics, it is very difficult to transfer the energy. Clear? So the main object of today's session is, first I will try to go through the fundamentals, right? Why electric motor is in vehicle application. Next, how to identify the control variables in electric drive. Whatever variables we are going to identify, these variables are common for all electrical drives. Even if you take DC drives or AC drives or special machines also, control variables or target variables will not change. Our system is motor. What is the function of motor? What is the function of motor? Basic function of the motor? Basic function. What is the expected output of the motor? If you take any motor, expected output is torque. Torque is the parameter. Because of torque, you are getting speed. Because of the speed, we are able to control the position. You got my point? The basic primary element, right? The expected output of the motor is a torque. This torque is mainly because of the, what is the input to the motor? Voltage. Because of the voltage, right, we can able to control the current with respect to electrical circuit. By control the current effectively in electrical circuit, we can control the flux in magnetic circuit. By control the flux in magnetic circuit, what will happen at the end? See, magnetizing flux and armature current both will interact with respect to each other. It will generate the twisting force. Finally, see, if you take motor, any motor, DC motor or AC motor, it will produce the twisting force. Torque is the expected output. Now my question is, see, as an electrical scholar, the logic, whatever logic is there behind the electrical voltage, whatever logic is there behind the mechanical potential element, where torque is the mechanical potential element. If you want to produce the voltage, what it required, there is a common principle is there. Even if it is a DC generator or AC generator, what is the common principle behind to generate the EMF? What it required? There is a standard principle is there. Standard method is there. Standard, see, constraint is there. You have to fulfill that constraint so that we can able to produce voltage. What is the standard constraint? You need to maintain relative motion. No option. We don't have any option. If you want to produce the voltage, you have to provide relative motion, right? Whether it is a DC generator or AC machine or transformer also. Even if you take transformer, essential thing is you need to maintain finite relative motion, right? If you maintain finite relative motion between the magnetizing flux and conductor, you will get twisting, you will get electrical force. Clear? Now my question is how to generate the, what is the main constraint to produce the mechanical force? Torque is called mechanical potential element. If you want to do any job in electric circuit, it required voltage. Voltage is the primary component to do any work in electrical circuit, right? With respect to mechanical circuit, torque is the primary cause component to do the mechanical job. If you want to if you want pull or push, or if you want to lift the luggage or anything, it required mechanical force. Torque is required. Force is required. Now, see, torque is the main cause component in mechanical system to do mechanical job. Clear? Now, my question is very simple. If you want to produce the twisting force or torque, what condition or what constraint we need to satisfy? Anyone? See, finite relative motion is required whether it is a DC generator or AC generator. You need to maintain finite relative motion between the conductor and flux. Then only you will get EMF. EMF is mainly because of finite relative motion. Now my question is how to get how to generate the torque. There is a standard. I am not asking about mathematical model. Later I will come. See, in today's session, I will try to focus mainly on mathematical model. I am not asking about mathematical model. I am asking about philosophy behind to generate the twisting force. See, if you want to produce twisting force or torque, whether it is a DC machine or AC machine or synchronous or asynchronous machine or special machine, essential thing is you need to maintain zero relative motion between magnetizing flux and armature flux. This is a very important point which is common for all electrical motors. If you maintain this condition, right, definitely here twisting force is a finite value. If you are unable to satisfy this constraint, there is no output force, output torque in machine. You got my point? See, I will repeat once again. If you take any motor, at any instant of the time, you need to take care about what is this speed difference between magnetizing flux and armature flux. Relative motion. This relative motion must be zero. Right? See, in case of DC machine, armature flux is always in the pole axis. Magnetizing flux is always in phase with pole axis. Armature flux is in phase with brush axis, right? With respect to each other, both are looking like stationary. You got my point? So if both are looking like stationary, then only both will interact, it will generate the twisting force. Even in case of induction motor, even though it is an asynchronous machine, magnetizing poles and rotor both are not rotating at same speed. Rotor conductor speed and magnetizing poles speeds are different. You got my point? But even operating speed of the rotor and speed of the magnetizing poles are different, but if you see the relative motion between the magnetizing flux and armature flux produced by the rotor conductor always matching with your supply frequency. You got my point? Speed of the stator pole is matching with supply frequency, speed of the rotor poles also matching with stator frequency at any moment, right? So if you verify the relative motion between the stator flux and rotor flux, it is always 0. Even if you take synchronous machine at any instant of the time, under steady state condition, NS and NR, see rotor poles, speed of the rotor poles and speed of the stator poles, relative motion is 0. Why there is no starting torque in case of asynchronous machine? Reason is initially, right, there is a finite relative motion is there between stator poles and rotor poles. Initially, if you take synchronous machine, your rotor poles are stationary, but stator poles are rotating with 1500 RPM. So if you verify the relative motion between the stator pole and rotor pole, there is a finite value is there. Because of this reason, your machine is unable to generate the twisting force. If you want to produce the twisting force, mechanical potential element, essential thing is 0 relative motion is required. The beauty of commutator in DC machine is it will take care. In case of DC machine, your commutator will take care about the relative motion between the stator flux and rotor flux. It will maintain, it will take care. You don't need to do anything. Even if you take asynchronous machine, induction motor, you know about slip? S. Slip will take care everything. I will tell. Best example, what is the speed of the participants? 0. You all are stationary, right? So what is the speed of what is the speed of speaker? 0. Right? What is the relative motion between participants and speaker? 0. With respect to each other, relative motion is 0. That's why we are interacting. Otherwise, if participants are stationary, if speaker is running with some finite speed, interaction will there is no, I cannot transfer the energy. You got my point? Otherwise, speaker is stationary, participants are running with some finite speed, no interaction. You got my point? At any instant of the time, whether flux is rotating or flux is stationary, magnetizing flux is stationary or rotating, right? See, relative motion between the stator flux and rotor flux must be 0. Clear? If you clear this one, definitely you will get clarity about the how to identify the control variables. Our second topic is identify the control variables in electric drive, right? Then after that, what type of electric motors they are adopting in a vehicle application we'll try to discuss in detail. Then classification of speed control techniques. Next, design of control parameters. Particularly, I will not go in detail. Particularly, see, our main objective is understanding the philosophy behind the predictive control scheme for electric drives application, right? Next, what is the main motivation for MPC method? What is the basic difference between conventional PI controller and model predictive controller? I will try to explain in detail in today's session. Next, what are the classification of model predictive control method? What is the significance of finite control method? Why finite control method, finite control set method become so popular in industrial application as well as research point of also many scholars they are adopting finite control set method, right? Next, after that, simulation studies we'll try to discuss in detail. Next, what are the challenges in MPC scheme? We'll try to. This is all the content of today's presentation, right? See, electric motor is a part in the it is drive is nothing but see motor, controller, power converter, feedback, everything is coming under drive. Drive is a, see, it is a very mechanism, big mechanism. How many of you from electronics? Many participants. Then it is very challenging for me again. Sorry, computer science also. Oh, if it is very challenging for me to transfer the energy to the computers as well as electronic scholars. If see, my focus is on control only. See, please try to understand. No problem. If you are having any basic doubts, you can ask. My question is, that's why I'm telling. Many scholars, they're worrying about, see, how to develop the control system, how to understand the model predictive. They are worrying about the control mechanism, but they are not focusing on the system. I'm telling, important point. Let us assume that there is a 1 hour time is there for you, right, to develop control logic. Please try to understand, 45 to 50 minutes you have to spend for understanding the characteristics of the actual system. If you know the behavior of the system, characteristics of the system in terms of mathematics, in terms of characteristics, in terms of, right, everything. If you know the in detail behavior of the system, it is not a big deal to, within 5 minutes we can develop the logic, control method. You got my point? Clear? So what I am doing here, first I am trying to explain the system behavior. My focus is, if I enter directly to the model predictive controller, if I explain the model predictive controller with respect to induction motor or PMSM machine, participants will run like anything. They cannot understand. So see, what I am trying to is, see what is the need of model predictive control. If you want to develop control logic, first how to identify the target parameters. This is very important. What parameter we need to control. Without knowing the control parameter, it is very difficult to develop the logic. You got my point? Next, one more important thing is, if you take any system, if you want to develop control mechanism for system, right, without knowing the control variable, we cannot develop the hierarchy. You got my point? Building the hierarchy is a very big challenging for electrical scholars or any scholars, right? Clear? You know about hierarchy, control hierarchy. What is hierarchy? Sequence. Take best example, institutes. If you take any institute, even if you take NITs or IITs, or even if you take private university also, they are following standard hierarchy. Everyone is adopting standard hierarchy. What is the hierarchy? Students are controlled by the faculty. Faculties are controlled by the HODs. HODs are controlled by the deans. Deans are controlled by the director. You got my point? But actually, who is working really? What is our target parameter? This is the sequence. Student and faculty is most inner loop. Am I correct or not? That is called most inner loop. Then after that, what is the loop? HOD loop. Right? Then after that, what is the loop? Deans. All deans are working under. So who is most outer loop? Director. Now, see, actually, if electrical scholars are there, I can explain in terms of bandwidth. You know about bandwidth? What is bandwidth? I am not asking definition. What is the significance of bandwidth? Suppose there are A and B students are there. If A student bandwidth is 1000 Hertz, if B student bandwidth is 2000 Hertz, what will happen? The ability of the B student extracting the, or what is the ability of the B student? If B student bandwidth is more, ability is he will track the reference very fast. You got my point? He is having more ability to track its reference. Within short period, he will understand the concept. It will not take delay. But A student, bandwidth is very less. If bandwidth is very less, we don't have any option. You need to adopt control mechanism. The beauty of control system is, by adopting the control mechanism, we can able to improve the bandwidth of the actual system. By nature, most of the systems offer less bandwidth. We don't have any option. By nature, if you take any system, right, it will offer poor characteristics. Nothing but with respect, all systems practically all are in lazy condition. Lazy nothing but that is the nature. Pole position of the system are very closely to origin. If pole is closely to origin, issue is, what is the issue? You know about pole zero at least? Control system? Then tell me. If pole is, see, by nature, if you take any system, what is the need of control mechanism also we have to understand. By nature, if you take any system, right, pole is always, dominant pole is closely to origin. If pole is closely to origin, issue is system will not respond immediately. You got my point? Whatever input you are giving, even if you apply some force, your actual system will not respond immediately. That's why it required control mechanism. By adopting the mechanism in proper, by using proper sequence, definitely we can improve the bandwidth of the system. So if system bandwidth is improved, what is the advantage? If system bandwidth is improved within short period, your system will reach to steady state. You got my point? It will not take much time. Immediately your system will reach to your reference point. Whatever speed you required, your system will respond to your reference value. Clear? So that's why I am telling in today's session, by taking one example, I will try to explain what is the significance of controller. Without controller, with controller, mathematically I will try to explain so that you will get more clarity about what is the need of feed forward controller. Feed forward controller is very important controller, right? But where we need to adopt this controller is very important. If you want to adopt some control mechanism, first you should know whether this feed forward control or model predictive control really it is required or not. You should know. You got my point? Whether need is there or not, you need to get more clarity. As a scholar, you should know whatever method you want to adopt, whether that method will give the required response or not. You have to justify, right? So this slide will give the significance of electric motor compared to IC engine. By taking various parameters, right, we can identify what is the importance of electric motor in application, right? See, even if you take IC engine or even if you take hydraulic engine, basically all are mechanical energy producing device. You got my point, right? Instead of taking IC engine, if you take electric machine, what is the advantage? What is the advantage with electric machine? If you replace IC engine with electric machine, that's why electric vehicles become so popular. If you observe one parameter, bidirectional, there is one parameter is there that is called bidirectional. With respect to bidirectional, what is the advantage if you adopt electric machine in vehicle application? Bidirectional power flow. Nothing but, see, same machine, it can operating in generating mode also. Whenever you want to apply brake or whenever braking mode is required or deaccelerate mode is required, the ability of the electric machine is it will enter in generating mode. But your IC engine never will enter in generating mode. You got my point? So once your drive is entering in generating mode, your power is feeding back to the source. During deaccelerating mode or braking mode, we can charge the auxiliary batteries in electric vehicle application. That is the significance of electric machine. That is the ability of electric machine. One more important point is, see, efficiency of the electric motor compared to other drives, it is more than 90%. Efficiency is more, what is the advantage? If efficiency of the drive is more, what is the advantage? Anyone? That is fine, losses, okay. Heating effect is less. With respect to system point, if efficiency is more, heating effect is less. If heating effect is less, advantage is you can operate more period. Reliability, it is completely depends on how much efficiency offered by the particular system is so important to decide the continuity of the operation. How much speed you need to operate, electric vehicle will decided by the heating effect. If heating effect is more, right, you have to stop the vehicle or you have to use some forced cooling methods. You got my point? See, efficiency will decide. Efficiency is a factor. How much energy is converting from one form to another form will decided by the efficiency factor. Remaining energy is decided, remaining factor 10.1, efficiency 90%, remaining 10% is converted in terms of heat only. You got my point? So see, by using efficiency factor, by using bidirectional parameter, we can highlight electric machine compared to conventional engines, combustion engines. So here now this is complete hierarchy of the electrical propulsion system. If you take any electric drive, this is the standard block diagram, not only for electric vehicle application, even if you take robotic application or aerospace application, they are following this structure. See, our focus is here. What is our focus? Our main focus is on, I will just in a minute pointer. See, our focus is on this one here. So this all are under software side. What are the things are there under software? Control methods. All control methods are coming under software side. This, see, whenever you want to develop some logic, right, through mathematics, we can do. Whatever equations you have developed to control the actual system, that equations you have to execute through hardware, controller, microprocessor or microcontroller or DSP or FPGA boards. By using control boards, we can execute our logic. Then after executing, if you take any electronic circuit, right, what is the expected output of the controller? Any controller. What it will give? Controller output. This one, take DSP. What is the output of the DSP controller? It will give control pulse. It will give gate pulse. You got my point? That gate pulse will apply to the power converter. Switch. What is the advantage of the switch? Power converter, nothing but inside there are switches are there. By adjusting the on and off period, what we can do? We can control the energy transfer from source to machine. By control the energy transfer from source to machine, we can control the characteristics of the actual system. By changing the characteristics of the actual system, right, we can satisfy the load. Our top priority is meeting the load requirement. To satisfy the load requirement, as a design engineer, you have to select the proper control method. By selecting the proper control method, we can able to control the energy transfer from source to machine. We can control by control the energy transfer from source to electric motor, right? We can control the torque speed characteristics of the motor. By controlling the torque speed characteristics of the motor, we can control the speed of the wheels. We can satisfy the customer. This is the standard procedure, right, for any electric drive system, right? Even if you take aerospace application or electric vehicle application, they are following this method. In today's session, our main focus on control mechanism. So see, I think for electronics students, they have not studied, I think they don't have transformation technique. You have not studied transformation techniques, right? Electronics or computer science. It is very, no, transformation, 3-phase to 2-phase transformation. It is very difficult to, why? Because see, nowadays no one is using DC drives, right? All are adopting AC drives. Problem with AC drives is minimum 3 phases required, or right? So optimal number of phases with respect to AC is 3 phase, right? If your actual system is in 3-phase model, right, whenever you want to control the 3-phase system, it requires transformation techniques. But model predictive control, everything is based on transformations only. Anyway, I will go very slowly. I will try to explain. How many electrical scholars are there? Can you raise your hand so that 1, 2. Electrical. 1, 2, 3, 4, 5, 6. Okay. Anyway, I will go very slow. I will try. I do. Next. Oh. See, my area of specialization is power electronics and drives. Hmm. See, please try to understand. See how they are adopting the model predictive control in electric drives. Try to understand. Same thing you can apply to your system. System to system, what will happen? Characteristic equation will change. Target parameter will change. You got my point? So based on your system characteristics, as a scholar, you need to identify what are the target parameters. Once you know the target parameter, see, you need to identify what is the hierarchy to control that parameter. If you know the hierarchy, it is not a big deal. Clear? At least if you know the fundamentals of DC machine and AC machine, it is easy for me to transfer the energy effectively. So here our main target parameter is, so main object of today's session is control, model predictive control. So with respect to controllability point of view, right, if you compare the performance of DC machine and induction motor or other machines, so with respect to controllability, DC motor got highest point. But other all machines, induction motor, PMSM, SRM, hybrid machine got less. Maximum marks 5. DC motor got 5 out of 5, but other machines got less than 5. Now my question is, why controllability of the DC motor is very good compared to AC drives? What is the reason? How to decide the controllability? That's why I'm telling. If you understand in detail about the actual system, it is not a big deal to identify the controllability, power density, efficiency. Everything will come based on the actual system behavior or characteristics. Clear? So what I will do is I will try to take simple equations so that based on simple equation I will try to explain so that you will get at least minimum 50 to 55% concept. Even if you understand delta x is also fine to me, no issue. Clear? Now tell me here, why DC machine with respect to DC machine, this one, with respect to controllability point of view, DC motor got 5 out of 5. Construction, no. How to decide? How we can decide? See what is the main parameter? See, will decide the controllability of the system. Very good, torque. So controllability, it is completely depends on the torque profile. Clear? Torque generated by the machine. Based on the torque profile, we can understand the controllability. Why? Because see, whenever you want to understand the behavior of the system, or whenever you want to decide the performance of the system, see, with respect to student, how we are deciding the performance based on the CGPA. After writing examination and after evaluation, right, we are giving the grade to the students. Based on the grade, we can classify the students. So CGPA is the main parameter. With respect to CGPA parameter, we can classify the performance of the students. We don't have any other option. Am I correct or not? So with respect to, right, our system is a motor. With respect to motor point of view, right, controllability is decided by the output parameter of the system. Output parameter, if you take any machine, motor, expected output is torque. Based on the torque profile, we can decide the controllability. Right? So this is called universal torque expression, which is applicable to all electrical drives, all electrical machine. Right? Even if you take DC machine or AC machine, this equation is applicable for all electrical. That's why it is called universal torque expression, potential equation for all electrical machine. Right? In case of DC machine, the beauty of DC machine is by adopting the commutator, we can maintain delta. How much in case of DC machine? 90 degree. If it is a 90 degree, then so this one sin delta become 1. What is the advantage? See, so how many variables are there in torque expression? There are 2 variables. If delta is a variable or constant. In case of DC machine, by taking care about the armature reaction effect, at any instant of the time we can able to maintain delta 90 degree. Throughout the operation we can maintain delta 90. If delta is delta 90 degree, see the number of variables involved in the torque expression will coming down. If number of variables are decreases, advantages with respect to control point of view, burden on the controller will coming down. You got my point? So here how many variables are there? 2. Delta is nothing but angle between stator flux and rotor flux, where delta is the angle between these 2 flux, right? Now see what is the order of this equation, how to decide order? What is the order? What is the order of this equation? Order is it is a second order system. But now my requirement is I want to control the torque instantaneously. Second order is a linear or non-linear system? It is a non-linear. Non-linear systems, by using non-linear system, we cannot expect, you should not expect high performance. Even though it is a second order system, if you want to improve the dynamics instantaneously, it is not possible. In case of DC machine, by nature, it is in non-linear condition. But good thing is number of variables are only 2. You got my point? So you know about armature voltage control method? In armature control method, see throughout the operation we are maintaining stator flux constant. If stator flux is constant, advantage is second order equation will convert it to first order. So here we are not changing any physical parameter, we are not replacing something, or we are not adding, or we are not modifying with respect to physical point of view. Only thing is mentally, see by adopting the control mechanism, by using armature control method, what we are doing is we can change the characteristics of the actual system. By applying the armature control method, what is happening? It is a technique, engineering technique. You got my point? So by adopting armature voltage method, see the characteristics of the motor, we can convert it from non-linear to linear. Now what is the advantage? If it is in linear mode, if it is in first order, what is the advantage? We can change the torque, we can able to control the torque instantaneously. If number of variables are more in your mind, it is very challenging for me to transfer the energy. If there is only one variable is there in your mind, it is very easy, instantaneously I can able to transfer the energy. You got my point? What I am trying to say, if number of variables are more, it is very difficult to control. If number of variables are more number of feedbacks are required. If number of more feedbacks are increases, number of PA controllers, or even if you take model predictive controller, what will happen? Target parameters will increases. You got my point? Now here what we are doing here, if you understand this point, definitely we can understand the model predictive control with respect to motor. I am telling, see, even if you take DC machine or AC machine, right, control the torque principle philosophy, it is common for all electrical machine. Don't think DC motor control principle is different, AC motor control is principle is different, or special machines principle is philosophy. See, concept is same concept, but execution is different. Methodologies are different. Based on the number of variables, right, we are changing the method. In armature control method, DC motor, we are focusing on only field current. By controlling the field, right, by maintaining, right, IF field current constant, advantage is nonlinear system become linear. If it is a linear mode, instantaneous control is possible. Instantaneous torque control is so important in high performance application, electric vehicle application, aerospace, robotic application. See, their requirement is torque, right? they want to control instantaneously. If torque is controlled instantaneously, we can control the position or speed instantaneously, right? Now here, if there are two things are there. What we are doing here, tell me if you understand this one. Now we are, see where torque is the expected output of the motor, where torque is the potential element, right, produced by the motor. By using this potential element, we can do mechanical jobs. Am I correct or not? Now thing is, see now with respect to torque profile, how many target parameters are there? With respect to motor side, how many parameters we are targeting? Initially, before controlling the torque, we are controlling the flux. You got my point? We are maintaining field flux constant. Initially, we are controlling the flux. So by controlling the flux initially, by maintaining the field flux constant initially, advantages torque control become very simple. Whenever you want to teach the concept to the students, first you have to create good environment. Am I correct or not? See, if you take any machine, electrical system, if you want to do any job, it requires reactive power. Reactive power, what it will do? It will provide the environment to do real job. If you want to do real job, if you want to convert electrical to mechanical or mechanical to electrical, it requires reactive power. Reactive power will provide environment to do actual real job. Right? Here also, right? See, by controlling the field flux, by maintaining the field flux constant, torque control becomes simple. So as an electrical scholar, whenever you want to control the torque, initially you need to control the flux. So finally, what are the target variables? Our target variables are two. One is torque controller. Torque is the primary objective. Second control parameter is flux. So, right, even if you take conventional methods or conventional PA control based methods or model predictive control method, our target parameter is torque and flux. How we are going to control the torque and flux, particularly in electric machine, right? Now finally what we identify the control parameters. Once you identify the control parameter, next immediately you have to identify the hierarchy. You need to decide the hierarchy. What hierarchy we need to follow? Whether it is a PA controller base or whether it is a model predictive base, you need to identify the hierarchy. Identify the hierarchy is very important, right, to control the parameter effectively. Otherwise, it is not a possible. It is, if you are not following hierarchy, we cannot transfer the energy effectively. We cannot change the characteristics of the motor based on the load requirement, right? Now, if you take induction motor, what is the order of the induction motor? Now, electrical scholars, you can respond. Electrical scholars are there, right? Now, what is the order of the torque profile of the induction motor? You forget about now number of electrical scholars are less. I will not go in detail about synchronous machine. I will take only two topics. These two topics, with respect to these two topics, I will try to complete my session today. Now tell me, what is the order of induction motor? In case of induction motor, no brushes, no commutator. Clear? Then delta is not a constant. It is a variable. In case of induction motor, delta is a variable. This is also variable. Next, lambda r and lambda s is also variable, but where lambda s is nothing but resultant stator flux due to A phase, B phase, C phase. Inherently, there are three components are there. Similarly, rotor side, A phase rotor flux, B phase rotor flux, C phase. It is a three-phase system. So, see, if you take lambda s, it is mainly because of interaction of the three stator flux. Lambda r is also interaction of the resultant of three rotor flux. So, 3 plus 1. So, what is the order? 7th order. You got my point? Now you can think, if number of variables are more, what is the issue? Control is difficult. More number of feedbacks. If you want to control the torque, you should know, right? A phase, B phase, C phase, stator flux information, right? Rotor, A phase, B phase, C phase flux, rotor information is required. With respect to lambda s, 3 feedback signals are required. With respect to rotor side also, 3 feedback signals are required. Next, space displacement angle between stator flux and rotor flux is also required. Why? Because it is not a constant. It is regulating instant to instant based on the operating frequency, based on the supply voltage, right? If there is any disturbance is there suddenly on the shaft, definitely delta will regulate. So number of variables are 7. Now control complexity is more. But my question is, why industry people? If you take any industry, all are adopting induction motor. 85 to 90% electrical drives are operated with induction motors. What is the reason? Even if you take Tesla car, initially they adopted induction motor for traction purpose. In electric with respect to controllability point of view, with respect to torque profile, DC motors are very strong. Now example I will take. Let us assume that there are two students are there in the class, right? A and B, right? So mentally A student is very good, technically is very strong, right? Whatever you are teaching, he will understand within short period. Mentally he is very strong. A student, expected grade in the examination is excellent. But B student, right? See, mentally he is not strong. Expected grade in the examination is C or D, you can expect. But thing is, the problem with A student is physically he is not fit. Physically he is not fit because of some health issue. He cannot run fast, or he cannot sit in the exam hall continuously half an hour. More than half an hour he cannot sit in the hall, exam hall, because of physical fitness. Then see, so expected grade is A, expected grade is excellent. B expected grade will take C. Assume that mentally he is not strong, but physically, see what is the exam, let us that exam time period is 3 hours. So after getting the question paper, the ability of the A person is he can answer all 5 questions. He can respond 5 questions. But issue is he cannot sit in the exam hall continuously 3 hours. More than half an hour he cannot sit. Why? Because physically he is not good. B student, the ability of the B student is he can sit in the exam hall continuously 3 hours. But what is the problem with B? He cannot attempt all questions. Only 45 to 55% he can answer. But who will get grade after examination? After examination, who will get grade, B or A? Hey, after the ability of the A is he can attempt all 5, but he cannot sit in the, he cannot write exam continuously. More than half an hour he cannot sit. Right? So who will get grade? B will get C grade. So placement people, they will select C. Am I correct or not? Placement people, they will select B person. So what is the challenging? After that, what is the big challenging? After selecting the B person with respect to company point of view, industry point of view, what is the big challenging? Their target parameter is physical parameter or mental parameter? Mentally they will train the B person. They will try to improve the mental characteristics of the B person. Similarly, with respect to electric drive, DC motors mentally very strong. Torque profile, order is in second order, but induction motor order is 7. Dynamic response is very poor. Mentally very poor, but induction motor lifetime is 70 to 80 years. If you want, you can operate continuously more than 3 months, 4 months, nothing will happen. But DC motor, we cannot operate more than 40 hours or more than 24 hours also we cannot operate with maximum load. Right? Reason is, what is the problem with DC motor? Commutator is the weakness. The strength of the DC motor is commutator, weakness is also commutator, both. So here A person is nothing but, with respect to our example, DC motor. B is nothing but AC motor. The ability of the AC motor is it can run more hours. Reliability, maintenance is 0. No brushes, no commutator, it doesn't require maintenance. The ability of the induction motor is it will occupy very less space. Particularly space is a main constraint in aerospace application, electric vehicle application, in submarine application. There is a limited space is available for mechanical energy producing device. You got my point? There is a limited space is available for drive part. If you take DC motor, it will occupy more space. Clear? Understood? So that's why here issue is, here the object of this slide is, by using this slide we can understand what is the significance of AC drives. AC drives mentally very poor but physically very strong induction motor. So by adopting the control mechanism, by adopting the model predictive control method, we can improve the mental profile. How we can improve the mental profile? Right? By using engineering technique. You have to adopt technique, armature control. By adopting the armature control method, what happened with respect to DC drive? Second order system is converted to nonlinear, system is converted to linear. Similarly, see, there are advanced vector control methods are there. Model predictive control will come under vector control technique, advanced method. By adopting model predictive control method, what will happen? Higher order system, seventh order system will converted to first order. You got my point? So see, after adopting some mechanism, after adopting some technique, engineering technique, mathematics technique, as well as by taking the combination of power electronic module, by combining these two, right, we can able to change the characteristics of the B person similar to A. You got my point? We can change the characteristics of the induction motor similar to DC motor. DC motors are called benchmark machines, but practically these machines, they are not adopting, they are not using DC motors practically, but they are taking as a benchmark with respect to torque profile or with respect to performance wise, right? All industries, they are taking DC motor as a benchmark to improve the excellent student. See, what is the benchmark in class? A person is a benchmark, clear? But he is unable to write the examination. So here, how we can improve these are the challenges. If you take AC drives, right, main thing is you need to take care about the nonlinear component in the torque expression. See, with respect to drive system, see, torque profile is a very important. So same thing, whatever system, see, whatever work you are doing for particular system, you have to identify what is the potential element with respect to your system. You got my point? What is the expected output of your system? You need to identify potential element. See, if you identify the potential element of your system, right, it is not a big problem to identify the order of your system. If order is less, control ability is very good. If order is more, control become very complicated. But induction motor, order is more, torque profile is very poor, number of variables are more. That's why, see, eliminating the nonlinear component in torque expression is a very big challenging, right? If number of variables are more, control complexity is increases. Control complexity is more, what is the issue? It requires lot of instructions, right? If number of instructions are more with respect to computer science point of view, if number of instructions are more, what is the issue? We cannot take more number of samples per second. You got my point? We cannot take more number of samples. If you take more number of, see, let them that, see, instruction, particular instruction, if you want to execute, 1 microsecond is taken. Same instruction, same method, we can write with lengthy program also, right? Instead of taking 1 microsecond, let them that second program is taking 10 microseconds. What is the issue? Number of samples are coming less. If number of samples are less, you will lose accuracy. Clear? Here also, once accuracy is decreases, definitely steady state characteristics will get effect. Steady state performance is completely depends on, see, what is the percentage, how many samples, what is the execution time of your logic is so important. Execution time is how, see, now how to decide the execution time based on your instructions, right? Once you know the execution time, it is not a big deal to identify the sample time of the system. Whatever sample you are taking, that sample time should be always greater than the execution time. This is a very fundamental principle common to any electrical engineering, whether it is a control, whether it is electrical engineering or electronics or computer science. Basic principle is right? Whatever sample you are taking, whatever sample time you are taking, within the sample time, you have to complete the task. You have to execute the logic. After executing the logic, you will get some output parameter. You have to store somewhere else. You have to store some, right? You have to store the data. Sample time, it is fixed. It will not vary. Sample time, it is not under your control. Sample time is decided by the execution time. Execution time is decided by the how many instructions are taking to control the variables. It is completely decided the length of the program. If length of the program is more, execution time is more. If execution time is more, let us that execution time is 1 microsecond, sample time you have to take more than 1 microsecond. This is thumb rule. Otherwise, let us that, see, if you take sample time 1 microsecond, but execution time is 1.5 microseconds, what will happen? What is the issue? After completion of the sample time, there is no execution, you have not completed the task, what will happen? There is no signal to the power converter. There is no signal transfer to the power converter. If there is no signal to the power converter, what will happen? Energy we cannot control. See, after completion of the sample time, right, your system is expecting the control pulse. Your power converter is expecting the control pulse from the controller. There is no output from the controller for particular sample. Definitely your system, we cannot meet the load requirement. Please start to understand. See, sample time, in general, they will calculate based on the execution time. First, you should know what is the time taken for completing the task. You should know, right? See, based on the execution time, we can decide the sample time. You got my point? Sample time should be always greater than the execution time. Sample time, it is not under your control. Execution time is under your control. You got my point? Same logic, if you write with less instructions, we can minimize the execution time. If execution time is decreases, proportionally you can minimize the sample time. No, I'm not, it is not a fix. See, based on, suppose, now my aim is control the induction motor. Suppose you take some scalar control method, execution time is 1 microsecond, sample time you have to take more than 1 microsecond. Throughout the operation, that time is fixed. Clear? Sample time, right? Initially, sample time you have to define. How to define the sample time? Based on the execution. See how much time is taking to get the information is so important. Once you know the execution time, it is easy to decide the sample time. Clear? Now, these are all the methods, these are all the techniques to overcome the challenges whenever you want to improve the profile, student profile or physical motor profile. These things are standard things. So, what is the first point? Understand the machine behavior. You have to understand the system behavior through mathematics. I am telling mathematics, many scholars, computer science or electronics or electrical scholars, they are thinking about mathematics. It is a subject. Please try to understand, it is not a subject. It is a language to understand the behavior of the system in detail. Right? Instead of reading 2 pages or 3 pages theory, if you analyze the one equation in detail in different direction, right? Definitely you no need to read 2 or 3 pages theory. You got my point? We can save time. We can understand the concept in detail if you adopt equation. Mathematical model, nothing but it is a technique. That's why mathematics, it is not a subject for engineering. It is a language. Each and everything. Good thing for electrical engineering is for each and every concept we can express in terms of mathematics by taking some approximation. You got my point? We're having proof. All machines or all systems, electrical system, we can represent in terms of mathematics. Model, that is nothing but modeling of electrical system. Once you know the mathematical model of particular system, we can easily extract the characteristics. Once you know the characteristics, we can easily identify the application. Right? So, next another important technique is transformation. Transformation with respect to, see our system is a 3-phase system, but here whenever you want to control the 3-phase variables, it is not a simple task. See, before explaining the transformations, I want to show one picture. This one. This picture will give significance of the transformation technique. Anyone? What is the significance of this picture? What is the application of this? This is engineering technique. It is also very popular. Wherever sharp curve is there, particularly in the hills area, they are adopting this technique, engineering technique. Now tell me, what is the purpose? What it will do actually in a particular application? What is the primary object of this mirror? This is called corner mirror. Generally, they are adopting corner places. Wherever sharp curve is there, they are adopting this mirror. What is the primary object of this mirror? What it will give? Let us assume that there is a one person. Let us assume that our reference person is coming from, see, left to right. If there is any vehicle is coming from right to left, then through this mirror, our reference person can able to identify if any vehicles are coming opposite or not. He can get the information. The primary object of this mirror is getting information about the opposite vehicles. Once you know the information about the opposite vehicle, what is the advantage? We can control the speed of the vehicle. If there are no vehicles, you no need to control. Even though it is a sharp curve, you can reduce the speed and you can move. Right? If there is any big vehicle is coming opposite, right? Heavy load vehicle is coming, you have to stop. Any vehicle, any car is coming, small vehicle is coming, you can reduce or you can go side and you can see. Advantage of the primary object of this mirror is it will give information. See, based on the information, what we are doing? We are controlling. You got my point? There are two things are there. Getting information is so important before control the system. Many scholars, they are not following these things. That's why it is taking delay to executing their problems, their research problem. Whenever they are working on some research problem, why it is taking delay? They are not concentrating on these two things. They're focusing on always control. They are forgot about how to extract the information from the actual system. They are forgetting. They are not concentrating on getting the information. You got my point? So this transformation technique will give information about the actual system in terms of two-phase variables. By adopting the transformation technique without losing any property, right? There is no change in the actual system proper information. Right? Whatever information is available in three-phase system, same information, right? It will give using two-phase variables. Right? So this mirror, anyway, right? This mirror will give information about the actual system. Once you know the information, we can easily control. Control, it is not a problem. Please start understand. That's why I'm telling. See, within 1 hour, if you want to execute your logic, 45 minutes you have to spend for extracting the information or understanding the system behavior. Once you know the system behavior, characteristics of the actual system, it is not a big deal. Once you get the information through feedback, right, it is not a big deal to control. But many scholars, they are worrying about control. Sir, I am unable to get the results. Issue is they are not understanding the actual system behavior. Their feedback system is not working effectively. Right? So this is about transformation technique. So by adopting this transformation technique, what will happen? See, whatever information is available in three-phase system, this is about three-phase system. Actual system is always in induction motors or special machines, synchronous machines, always in three-phase only, practically. Right? So using three-phase variables, it is very difficult to develop the control logic. That's why what they are doing is they will apply Clark transformation technique. It is a method, mathematic technique. By applying the Clark transformation technique, what will happen? Three-phase variables will convert to two-phase. But here issue is still your variables are in AC nature. Why variables are in AC? What is the reason? Why three-phase? You forget about Clark transformation. Now I want to ask one fundamental question. Why our signals are always AC? Anyone? why we need to apply alternating voltage to the motor? Take induction motor or synchronous motor or special machine, if you take any machine, why we need to apply alternating signal? Basic principle. What is the see? When we need to apply AC, when we need to apply DC, there is a concept is there. Standard principle is there. When we need to apply AC, if winding is stationary, if coil is stationary, you need to apply alternating. Then only you will get voltage. Then only you will get back EMF in the coil. Back EMF is so important to convert the energy. You got my point? So, in case of 3-phase, if you take induction motor or synchronous machine or special machines also, BLDC, PMSM, any machine, our stator winding is in stationary condition. If coil is in stationary condition, we don't have any freedom. You need to apply alternating signal. Then only you can able to produce back EMF. Clear? Now, here with respect to control point of view, right, this alternating signal is unwanted nature, right? So that's why later what they adopted Park transformation technique. By applying the Park transformation technique, what will happen? 2-phase variables are converted into 2-phase DC. Now even signals are converting from 3-phase to 2-phase AC or 2-phase AC to 2-phase DC. See, information it is not losing. Whatever information is there in 3-phase system, natural system or actual system, same information you will get even your variables are in DC nature. You got my point? So what is the nature of magnetizing flux here? What is the nature of flux here? Rotating. What is the nature of flux here? Rotating. What is the nature of flux? Resultant flux, air gap flux, rotating. In all cases, right, the behavior of the magnetizing flux is not changing. Flux is rotating in nature. So concept is, we are not missing any concept, but signals we are converting from 3-phase to 2-phase. We are converting. This is a engineering technique, mathematic technique. Mirror is a engineering technique. By adopting the mirror, right, you no need to get down and you no need to verify who is coming opposite or not. We no need to get down or we not. Simply your job is, see, by adopting the mirror, we can monitor the, you have to check the image, right, so that immediately we can control. Clear? Understood? So now my question is, why DC signals are required with respect to control point of view? Before discussing model predictive control, see, you should know what is the nature of control variables. Anyone? Why DC signals? You are asking something. Sorry? No. See, your feedback signal is in DC nature. Advantage is, what is the advantage? Our reference is always DC. Reference is DC, feedback is also DC nature, error is in DC. If error is DC, button on the controller become very simple. Only you need to regulate the magnitude. Otherwise, if error is AC, right, even reference is DC, finally your signal is in alternating nature. Right, in that case you need to take care about magnitude and phase. Position you need to control, but if error is in DC, only magnitude you have to concentrate. Button on the controller become very simple, very less if your actual signal or feedback signal is in DC. You got my point? So practically, even though your system is in AC nature, right, with respect to control point of view, by adopting this transformation technique, what will happen without losing any property? See, we are converting AC signal to DC. Once your signals are in DC with respect to control point of view, right, then it is easy to regulate the magnitude. By choosing proper Kp and K values, we can regulate the errors effectively, right? So see, this is the example. By taking this example, we can understand. See, even your inputs your actual system inputs are 3-phase in nature, alternating nature, right? What is the net power? Resultant power produced by the 3 phase is 300 volt amp. Even after applying the combination of Clark and Park transformation, right? Even 3-phase signals are converting into 2-phase DC, right? Is there any change in the net power? Information, there is no change in the information, right? This technique, what is happening? It is converting the signal, but it is carrying same information. You got my point? Break Altaf? Okay, just a minute. You got my point? See, our topic is model. Before entering into model predictive control, see what we have done till now. We identify the control parameters. What are the control parameters of our system? Torque and flux. These two are the target parameters, right? So, see, whenever you want to control the torque and flux control parameter, see what is the problem with our system? What required your control system? We identify. Our system is a AC system. Why we have taken AC system? What is the advantage of the AC system? Also we discuss. We have taken A and B example students. B student physically very strong. Induction motor is physically very strong but mentally weak. By adopting the control technique, we can improve the profile. We can improve the characteristics. Mentally we can improve. If student is not physically fit, as a faculty I cannot do anything. But if student is mentally poor, as a faculty, by adopting some techniques, I can able to improve his characteristics. By using some methodology, learning methodology, definitely I can improve the behavior, I can improve the characteristics of the student. You got my point? So here also design engineers, what they will do is, control engineers, they will try to understand the system behavior. See once you know the system characteristics, it is easy to develop the controller. So with respect to control point of view, feedback signals should be always DC nature. To get the DC signals, we are adopting this transformation. By adopting the transformation, what you are getting? You are getting information, same information with less number of variables. You got my point? So after break, I will try to explain about the see what is the need of model predictive control. Before entering the model predictive control, first you should know what is the problem with conventional PA controller. We should know. Now before break, can I ask one question? What is the problem with PA controller? Conventional PA controller. Then after that I will give break. We can take break. Okay. You are telling so many features not there in PA controller. You have explained very good. Now my question is, what is the problem with PA controller? PID or conventional PA control. Most of the engineers, most of the industrial application, we are adopting PA only. Derivative we are not adopting. What is P? What is the function of P? P is nothing but instantaneous, right? Transient time, it is completely dependent. Dynamic response depends on P value. I, based on the I, we can decide the steady state error. Now D, very good. Based on the D, we can decide the overshoots. Take glass of water, take bottle. Whenever you want to fill the bottle, initially it required P controller, like this position, right? Whenever bottle is coming 80 to 90%, then you have to change the position, right? This is called integrator. Then once water is coming closely to 100%, it required derivative. Derivative nothing but you need to drops are required. That is called derivative. you need to change position. Position of the bottle is so important, right, to control the flow. Initially this is the required position, later you have to change the position like this. At the end, to minimize the overshoot, to minimize the overflow, right, see, you have to change the position of the bottle complete. Now my question is, what is the issue with controller, conventional PA controller? Function, everything already you know very well. Now fundamental thing. After break you can think, okay, while taking snacks you can think. Think, see, if you understand the problem with PA controller, if there is any issue is there with existing controller, then only we have to move another controller, model predictive. If there is no problem with PA controller, we no need to adopt model predictive control, right? Clear? Whatever, see, hysteresis controller, PA controller, there is even if you take fuzzy logic controller, right? You got my point? There is a common issue is there. Think, you can discuss, this is not examination, like examination you can discuss among yourself, come with solution after break. Then see, first after break I will try to focus on what is the problem with PA controller. After that immediately we'll shift model predictive controller, okay.